So today in this video we are going to discuss about golden section search algorithm. Before that, let me introduce to you myself. I am Udhay Bhaskar from National Institute of Technology Andhra Pradesh from ECE department. Now let us understand what is golden section search algorithm. Golden section search algorithm is an optimization technique using which we can find the maximum or minimum value of a unimodular function in a specified interval. The objective of this video is to find minimum value of a function in a given interval using golden section search algorithm. So in golden section search algorithm, basically we find the minimum value or maximum value by successfully reducing the interval with the help of two intermediate points between the interval. Let's say the interval is a comma b, then we will find 2 points, let's say x1 and x2 between a and b. By using the function value at x1 and x2, we will reduce the interval size in each iteration. Now let's see how can we find that intermediate points x1 and x2 using these two formulas. Then we will find the function values at x1 and x2. If f of x1 is greater than f of x2, then we will eliminate the portion that is right of x1. Okay, else we will eliminate the portion that is to the left of x2. So we can easily understand the things seen over here. As f of x1 is greater than x2, the portion to the right is eliminated, and the new portion will be from a to x1. So our new b is equals to x1. These two formulas we can compute the intermediate points, the function values. Then here again function value is more at x1. In the similar way, we will eliminate the portion to the right of x1. In the next iteration, the b value is equals to x1 value in the previous iteration. Now we will compute again x1, x2 function values. Then here you can observe that f of x2 is greater than f of x1, so we will preserve our right side. So in this way we will find all the iterations. After some number of iterations, we can see the search interval is reduced to minus 0.96 and 0.84. So from minus 5, 15 to minus 0.96 to 0.84, we could reduce the search interval in just 6 iterations. So we need to perform some more number of iterations to compute the exact answer. So in the last iteration, we got a value is equals to minus 0.96 and b as 0.84. So in 7 iterations, we could achieve this. We will take the mean as answer with very less error. So this is the main function, and this is going to be find x1 function that takes a and b as inputs and returns the x1 value using a and b. Find x2 is another function that takes a and b as inputs and returns the x2, and we have initialized golden ratio to 0.618. Now initially we will compute the intermediate points x1 and x2 using find x1 find x2 functions. We will find the function values as well. First we will set some tolerance as 0.3, and we do the repetitive process using the while loop. Since the same logic we are going to use, if f of x1 is greater than f of x2, our new in the next iteration the b becomes the x1 in the previous iteration. X1 is going to be equals to x2, and x2 is we need to find again from the new interval using the formulas. If f of x1 is less than f of x2, we are going to do this. If they are equal, we have got the solution. So this is the output. So this is the function we have implemented in a compiler. So for the same example we have seen, we have got the same output. So in 7 iterations, they also have got approximately this thing only. So the application that we are going to see here is that efficiently searching an element in a sorted array. So if we use linear search for searching an element in a sorted array, we need to go through each and every element and check whether the element is our target or not. So first let's see how, if there are huge number of elements like 1 million elements, we need to iterate 1 million elements, then only we can tell that the element is found or not. A slight improvement to this is that, so since the array is sorted, if we found an element that is greater than our target, we can say that our target is not present in the array. This is the linear search code. We will traverse throughout the array and check whether it exists or not. If we found an element that is greater than the target, we return target not found, and that's it. So now let's see how we can use golden section search algorithm for finding the target efficiently. So first we take the search interval as 0 and array size. We compute 2 points, 2 intermediate points, mid1 and mid2. Similarly, how we found in the algorithm, if ARR is the array, if ARR of mid1 is greater than target, search in left of it, else search in the right of it, else search in mid1 and mid2. Now see, this is the main function that calls golden search algorithm. This is the array, n is the number of elements in the array, and let's say 100 is the target we need to find. Now this is the code for golden section search algorithm. So we will initialize left to 0 and right to n minus 1. We will compute mid1 and mid2 using the formulas we already seen. We do a repetitive task using a while loop. If we find x at mid1, we directly return mid1. If you find x at mid2, we return mid2. If x is greater than mid1, then x is greater than mid1, then we eliminate the right portion. That means we'll eliminate the portion that is to the right side of mid1 and compute mid1 and mid2 for the next iteration. Similarly, if AR of mid2 is less than x, we will eliminate the left side portion and compute the mid1 and mid2 for the next iteration. And else we can compute between mid1 and mid2. If element is not found, we will directly return -1. So this is how we can efficiently search an element in a sorted array using golden section search algorithm. So in this array of 1 3 5 7 9 11 12 13 14 15 16 17 19, if target is 15, if we perform the operation, the output is that element is found at index 9. When x is 5, element is found at index 2, so 0 1 and 2. If element is 10, which is not present in the array, we have found the output as element not found in array. So thank you.